Good morning, everyone. Yesterday, I have discussed regarding the kinetic gas theory. And from where we get the result that average kinetic energy of a molecule, of one molecule, we can say, is equal to 3 by 2 R divided by Na into T. Okay, that was the relation of the average kinetic energy of one molecule with the temperature. And if I am going to replace this R by Na with Kb, then what will be the equation is 3 by 2 Kb into T, average kinetic energy of one molecule. Okay, for one mole it is 3 by 2 nRT for 1 mole of gas. Okay, so you can get any question from these type of formulas. Okay, by giving Kb, Boltzmann constant. Although you know the value of the Boltzmann constant, that is Kb is equal to 1.38 into 10 raised to power minus 23 joule per Kelvin. Okay, temperature they will give you, and after that you can solve the numerical for the average kinetic energy. Okay, now we are going to discuss the Maxwell-boltzmann curve. Maxwell-boltzmann curve. The question that is going to be asked from this portion is the most probable velocity, root mean square velocity. They will give you the temperature and the molecular mass of the gas, and they are going to ask you what will be the root mean square velocity of the system, what will be the average velocity of the system, what will be the most probable velocity of the system, or most probable speed of the system. So Maxwell distribution curve, as you know, in a class suppose there are 50 number of students. Number of students is equal to 50. Okay, some of them are very weak in studies, means suppose 5 of them are very weak in study and 5 of them are very intelligent person, means 5 of them are almost 40% and 5 of them are above 90%. In this range, 40 students are in the range of average. So by this we can plot a graph of a class, that if I am going to plot a graph between the number of students and the marks distributed between them, the graph is going to be like this curve. Okay, so here on the x-axis I have marks distribution, and on the y-axis I have number of students. So if I'll see this portion of the graph and this portion of the graph, these are the marks distribution, means this is the marks distribution. How much? Suppose this is 5 marks, this is 50 marks, and this one is 90, and this is 100. Okay, so a very small number of students, very like 10 students have approximately scoring 5 marks, and almost 10 students are approximately scoring above 90%, but almost whole of the class is lying in between this curve. Okay, this area of the curve. So by this we can understand the molecules condition too. Suppose I have lots of gas molecules in my beaker. Okay, so these molecules are constantly moving because they have a large distance in between them, and they do not have that much force of attraction in between the molecules. Okay, so they are going to, what they are going to do, if they have a large difference or large distance in between them, and they are constantly colliding with each other and with the walls of container. So in the starting the molecule has different energy, but after colliding, different speed I can say, but after colliding with each other or walls of container, gas particles do not have the same speed as that present in the starting. Do not have same speed. Okay, so as the mass distribution of the class was like this curve, the speed distribution is also like this curve. I can plot the fraction of molecules on the y-axis and speed of the molecules on the x-axis. Okay, speed of molecules on x-axis. So a very few molecules have higher speed, few fraction of molecules have higher speed, and very few molecules have lower speed. Means this is the speed here, suppose 10 centimeter per second, and here 90 centimeter per second I can say. So most of the particle is in this range, and this one is the highest peak where the fraction of particles are highest. This is most probable speed. Okay, most probable speed, I can write it by UMP. This is the symbol of most probable speed, UMP. Now what is the we can plot two graphs. For when we are taking temperature constant, but the molecular mass of two gases are different, and other one when we are varying the temperature, means temperature doesn't remain constant. So we have two types of graphs in this. First, suppose I am taking higher molecular mass gas, that is chlorine. A molecular mass of chlorine is more than that of nitrogen. Okay, so if I can say a fat boy and a thin boy, I will take a fat boy as well as thin boy. Which one is going to move fast, fat or thin? Thin. So nitrogen is like a thin boy and chlorine is a fat boy. So if I'll plot, this is the speed of the nitrogen should be more, speed of molecules should be more, so it is going to look like this, and speed of chlorine is like, because the most probable speed of chlorine and the most probable speed of nitrogen, from that we can say that chlorine will move slowly than nitrogen. The speed of the chlorine, the most probable speed of chlorine is less than that of nitrogen. Okay, this is the plot. Suppose at 300 Kelvin, this curve is for chlorine, this curve is for nitrogen. Here I can plot fraction of molecules. I will plot. Okay, this is the curve when we are taking temperature constant, but mass is varying. If I will plot at varying temperature, means different temperature, at different temperature, So speed of molecule, because if we increase the speed of the molecule, as from the kinetic gas theory, average kinetic energy is directly proportional to temperature. If the temperature is going to increase, the kinetic energy is also going to increase. So speed of the molecules, fraction of molecules, okay. So if I'll plot the graph of the molecule at temperature T2, the speed will increase, and at temperature T1, speed will decrease, because as the temperature is going to increase, the speed of molecule is going to increase. One thing you must remember, that if the temperature increase, the curve must get broadened. Means the area of the curve getting broadened. And now there are three types of speed, or we can say two other types of speed other than most probable speed. Three types of speed are UMP, most probable speed, URMS, root mean square speed, and U average, average speed. Mean the formula of most probable speed is root 2 RT divided by M. Root mean square speed is root 3 RT divided by M. Average speed is root 8 RT divided by pi M. So what is T? Temperature. R is universal gas constant. M molecular mass. Okay, here pi is 3.14, you can put it. So if I'll plot the graph between molecular speed, then most probable speed is at the highest, UMP. After that U average, after that URMS. This is the fraction of molecule. And if I'll plot, URMS will always be greater than U average, will always greater than UMP. This is the most probable speed. Here from x-axis you can say that URMS will be the highest one. If I'll take the ratio of UMP, URMS or U average and URMS, what will be the ratio? That is 1:1.128, 1.224. I think you should remember this value, because it is going to take a lot of time to calculate in the exam. So you can calculate by dividing. If you want to see, I have UMP, U average, URMS, okay, root 2 RT by M, root 8 RT by pi M, root 3 RT by M. Okay. Now cut all the other values, like you can cut RT by M from three values, from these three values, root 8 by pi, root 3. Okay. After calculating this, you will get 1.28 and 1.224. And other thing is, as I already discussed with you, the ideal gas equation, that is PV is equal to nRT. For 1 mole, PV is equal to RT. So you can put in any of this, means URMS, if they are going to give you the pressure and the volume instead of temperature, then you can calculate it with that too. URMS is root 3 RT by M. You can plot it root 3 into PV divided by M. This is also the answer. And what is M by V? M by V is density. So you can plot you can calculate by density too. Okay, so this is all but about today's lecture, and after that tomorrow's we are going to discuss the numerical portion of kinetic gas theory, KGT, I have written the short form, and the MBT, Maxwell-boltzmann theory. Okay, we will discuss about these numericals, and first you have to read all the things of the Maxwell distribution law. Thank you so much for watching.